So, in that last video, it was all about given a cutoff value, finding the area under the curve. What we're doing here is reversing that process. Here we're going to be given a percentage. So either a percentage of people or things, it could come through as a probability, but it's given that percentage, and they're going to have some description of whether that percentage is going to the left, to the right, or between two values. But the idea is that from there, knowing where that percentage is landing, we can find a cutoff value. So this whole section here is finding a cutoff value given area under the curve. Whereas the last video was finding area under the curve given the cutoff value. So switching it around. A word that might be coming up in this section, it definitely is going to come up in this section, is the word percentile. Percentile implies area to the left, always. So this picture that I have over here where we have our bell-shaped curve, there's this cutoff and it's showing 70% to the left, 30% to the right. This cutoff that's separating that lower 70% to the upper 30%, so that's an X value, so that's a cutoff. And what that's describing is the 70th percentile. So when you see this word percentile, it's describing a cutoff point, creating that percentage to the left-hand side. So if let me do one more example with this. So if I needed to draw something where it's the 25th percentile, and I'm using the normal model, then what I would have is a bell-shaped curve. And what can help visually is that like halfway, so where the mean's landing, that's your 50%, 50%, like there's 50% of the data below, 50% of the data above. So this 25th percentile, I'm creating this 25% area to the left-hand side. So what I'm going to do is if I imagine that line at the mean, I'm just going to move to the left-hand side a bit because I need a smaller area to the left. So what I'm going to do is draw a line maybe here-ish, and that would be some X value. And what I would have here is 25% of the data to the left, 75% of the data to the right, and that value for X is the 25th percentile. So just being given that wording of 25th percentile, I can get a picture going. I know where the percentages are landing. What I don't know is the numbers on the number line. So this is called inverse normal probabilities, like I said at the beginning. So in that last video, we saw how to do like normal distribution calculations, finding probabilities. In this video, we're switching it around. That's the idea of inverse. We're inverting what we just did. So the function that we'll be using within Excel is equals and then norm dot inv. So it's a normal inverse. And what we'll be typing in is the probability, the mean, and the standard deviation. Now that probability that they want, that is always area to the left. And that's something that's going to change up. We might have to do area to the right. We might have to do area between two things. So with that, it'll be similar structure to that last video of where we might need to use a complement, or we might need to use a difference between two things and things like that, or we'll have to get a little creative. So, okay, let's go back to our rainfall model with Portland, and let's see, a mean of 40 inches with a standard deviation of 8 inches. So, X is defined by a normal model, mean of 40, standard deviation of 8. With these, I'm going to mark the mean. So I have these bell-shaped curves here. I'm going to throw in the mean right in the middle, but I actually am not going to number any more beyond that because it's a little difficult to visualize where these percentages are landing exactly. Knowing our empirical model, we can get pretty close, but I'm just going to keep it vague from here. Whereas in the last section where we knew where the cutoff was, having that full number line was really helpful. But this section, knowing the percentage, makes it tricky. So I have my bell-shaped curves there, 40 in the middle, but that's all I'm going to do in terms of numbering. So we want to shade and find the cutoff values for the lowest 10% of rainfall. So this lowest 10% is the idea of the 10th percentile. So what I'm going to have here on my picture, so I have my bell-shaped curve, 40 in the middle. I want to visualize this cutoff where 10% of the data is to the left, 90% of the data is to the right. Or in terms of area, 10% of the area is to the left, 90% is to the right. So the right-hand area is going to be huge, and that left-hand area is going to be fairly small. So I'm just going to draw a line kind of out here. So off to the left-hand side of 40, just so that we can kind of get a visual of, so if I shade the area to the left of the line I just drew, that should represent 10% of the area. And then to the right, we would have 90%. And actually, I'm going to switch this up a little bit because within Excel, we need to use decimals. So where I wrote 10% and 90%, I'm just going to switch that to decimal form. So to the left, we have 0.1, and to the right, we have 0.9. And what we're interested in is where did I draw that line? In terms of a scale of mean of 40 and standard deviation of 8, what is the number on that number line there where I separated these two areas? So if I kind of wrote probability notation for this, so we're going to the left, so this is the probability that x is less than or equal to, but I don't know what. I don't know what goes there with x. I don't know what that number cutoff is, but I know that that probability is equal to 0.1. So what we want to do is find what is the value that's going next to x there. So at the end of this, we're getting a value for x. So our cutoff value, and we need to go into Excel. So in Excel, since we're given area, finding a cutoff value, this is where we need to use that normal inverse. So I'm going to type in equals norm dot inv, and then it needs 3 pieces of information. It needs the probability to the left, which in this case they gave us that. So I'm going to type in 0.1, and then it wants the mean of 40 and standard deviation of 8. All right, let's go to Excel. I'll just go over here. So equals norm.inv. We have an area to the left of 0.1, mean of 40, standard deviation 8. Close it, enter, and we get a 29.7476. So x is equal to 29.7476. So that's where we're landing on our number line here. And we can start filling in more numbers and see if we landed about there, but that looks good. So this is the cutoff for the lowest 10% of rainfall. So how I would phrase this is the cutoff for the lowest 10% of rainfall is, and we take that x value, so that's measured in inches of rain. If you want to round that to a whole number, you can. In fact, let's go ahead and do that. Let's say it is about 30 inches of rainfall. Yeah. All right, so that's a scenario where we're given area to the left with that lowest 10%, or wording you could see as the 10th percentile. So this next one, they're saying the highest 5% of rainfall, which would be the equivalent of the 95th percentile. So highest 5%, we're visualizing this 5% to the right-hand side. So we're gonna have this teeny tiny area to the right, and then this great big area of 95% to the left-hand side. So on my picture, let's see, 40's in the middle. I'm just gonna go out to the right-hand side and draw a line so that it looks like about 5% to the right, so that's a 0.05, and then to the left is 0.95, and we want to know what is that cutoff value. So they're describing this 5% to the right-hand side, but what we need to use in Excel is the area to the left. So even though all the phrasing is about that highest 5%, is the same thing to talk about this lowest 95%. So what we're going to do is use the 0.95. So what we're doing is kind of using the complement of the area. So what we're looking for here is that the probability that x is more than or equal to some unknown is equal to 0.05, but finding that unknown, we're actually going to use this percentile value with that 0.95. So what I'm going to do is in Excel, I'm going to go equals norm.inv, so normal inverse, and then that probability, I'm typing in 0.95. So just notice that for that probability, since we were given area to the right, we just use 1 minus that area to the right. Okay, and then for the rest of it, so 0.95, comma, 40, and 8 for the standard deviation. So from that, we go to Excel, equals norm.inverse, we're using a 0.95 and 40 and 8. I'll give a 53.1588. So then the wording of the answer, we can talk about the cutoff for the highest 5% of rainfall. Is, let's go ahead and round to a whole number, about 53 inches. Okay, last one here. What if we are asked about the middle percentage, middle 50%? Something that's going to come up with this is we're going to use some symmetry. So let's go over to our picture. So middle 50%, so we're going to be centered around that value of 40. So we're going to have two cutoff values. We're going to have this lower cutoff value and upper cutoff value so that we have 0.5 in the middle, or 50% in the middle. So that lower cutoff value, let's go ahead and call that x1. And that upper cutoff value, let's call that x2. Now something that's going to be helpful is having the areas in the tails as well, specifically the left-hand tail, but let's go ahead and fill it in. So we have these three sections. We have this left tail, we have this middle 50%, and we have this right tail. So what we can do is use the fact that, okay, take out that middle 50%. What do I have left over? Well, I have 50% left over. So these two tails combined should make up 50%. There's symmetry here since this is all centered. I know my drawing's a little bit off there, but imagine it's perfectly centered. Those two tails should be exactly the same. So if we have this 50% left over, just cut that in half so that we'd have 0.25 for 25% in each tail. So the distribution goes left tail of 0.25, middle of 0.5, and right tail of 0.25. Okay, finding these x1 and x2 values we'll need to do separately. So let's start with x1, so that smaller value. So if I'm working with that smaller value, I need to think about what's the area to the left that we're given. So the area that's to the left of x1 is just that left-hand tail, which is the 0.25. So if I'm looking for this probability of x, how do I want to write this? Okay, what we're looking for overall, let's put it this way, is this probability of x1 less than or equal to our variable x less than or equal to x2. So I want to get out of this a value for x1. Oh, and sorry, that probability is 50%. And we want to get out that x1 and x2 values. So to find x1, in Excel, we're going to put equals normal inverse, norm.inv. And for x1, that area to the left is the 0.25. So we're going to type in the 0.25 for the probability, mean of 40, standard deviation of 8. And that's going to give our x1 value. So let's go ahead over to Excel, equals norm.inverse, 0.25, mean of 40, standard deviation of 8. And that's a 34.6041. So x1, 34.6041. And then for x2, we're going to do the same thing, but we need to think about what probability we use, or what is the area to the left for this scenario. So if I go back to my picture here, let's go ahead and get rid of the shading for x1. So x2, if I visualize this area to the left of that cutoff for x2, I have that middle 50% and that left tail together. So what we're going to do is add those probabilities, because we have this 0.5 and the 0.25. So for x2, that area to the left is 0.75. So that's coming from the 0.25 in the left tail plus that middle 50%. And then we have mean of 40, standard deviation of 8, and that's going to give our x2 value. If you're working in Excel, like we started the structure in that last one, you can just edit in the equation bar. So normal.inverse, and then instead of 0.25, I'm just going to change that to 0.75. Mean of 40, standard deviation of 8, and that's a 45.3959. All right, 45.3959. Okay, so answering the question, let's see, the middle 50% of rainfall in Portland is between, and let's just keep up with our rounding to a whole number, is between about 35 and 45 inches of rainfall. And again, in terms of showing your work, and I know I'm kind of maybe showing a lot here, you don't need to write out what you're typing into Excel, though it can be helpful. So if something goes wrong, then I can tell if anything was typed in incorrectly. So if you want to include that notation, that is kind of helpful for me. But be sure to show the exact answers, but then in the sentence, you can write it however you want. If you want to round to a whole number, if you want to use the exact values, that's fine. But like I've been doing with these examples, like this last one, I wrote that x1 is 34.6041, x2 is 45.3959, but then going to the sentence, round to what seems most logical for you.